Hey guys, Mr. Mises here, and this is lesson 9.4 for Calculus BC, and we're looking at vector definition. So here's a nice thing, guys. This is a lot of review, so if you remember this from pre-calculus, I guess this is a review from pre-calculus. If you don't remember pre-calculus, might have been a couple years for some of you, or you might not have ever gone over this, then, well, it's new for you. But it's not too hard. There's really not going to be much calculus in this at all. So it's pretty much the opening of what are vectors and how do we use them. So first of all, there is arc length of polar functions, okay, arc length in polar form. Now here's the good news for some of you is this is not required on the AP exam. So this is not going to be on the AP exam, but if you did want to do arc length of polar, this is the formula we would use. So in my class, we're going to go ahead and just treat this as extra credit. So if you see it on a test, it'll just be extra credit. But this is basically how you do it, okay? And then you just, get an answer in your calculator. All right, so that's polar arc length. All right, we're going to focus right now on vectors. So a vector, and some of you might know this, but vectors are, one of my favorite movies is Despicable Me. I love that movie, Despicable Me. This is not an advertisement for that movie, but one of the characters, the villain, the main villain, his name is Vector, and he says, because vector, like a mathematical symbol, that has both direction and magnitude, and that's what he says in the movie is why his crimes, he's committing crimes with both direction and magnitude. And so if you haven't seen that clip, it's one of my favorite clips. So a vector is a mathematical term that has both direction and magnitude. So sometimes we can just say this is a vector is a directed line segment. It has both direction and magnitude to that line segment. It's a line segment, even though it is written in array. So you see we have a line segment here with an arrow at the end. The arrow just tells me what direction it's going in, because if I had this line segment in the same place with the arrow that way, then it means it's going in the other direction, and that means something very different, because again, a vector has magnitude and direction. Both of them are important for a vector. So there is my vector. That is called the vector in standard position because it comes out from the origin. The magnitude of the vector, I'll say for this here, I'm going to call this vector V, and we can use a V with a little arrow on top as my vector. Sorry, I got to say vector every time. Like vector. But you could also use a bold. So you might see it as a bold on a, I can't bold here, but you would probably see it a bold in a textbook or something. So the magnitude of the vector is denoted by two double lines, like an absolute value. It's two double lines. And that magnitude is found by the square root of x squared plus y squared. Sometimes you'll see this as vx and vy, and these are the components. This is, so basically you're going to draw a little right triangle here. Let me zoom in here. We're going to draw a right triangle, and this is sometimes called vy, and this is vx. In this case, I'm just calling it x and y. And this point is going to be the point xy, right? And we've got an angle theta here between the x-axis and the vector. So our magnitude is the magnitude of this vector, right? Which in this case you could see easily. It's Pythagorean theorem. So square root of x squared plus y squared, right? The magnitude of this vector is x squared plus y squared. It's pretty easy to see that. The direction of the vector is usually found by that angle theta. And we could find that theta there by doing the inverse tangent, right, of y over x. Again, we're just using a right triangle. Now, if that vector is not in the first quadrant, let's say it's in the third quadrant, then we got to be careful, because the inverse tangent of, the inverse tangent of 1 is really just pi over 4. But if that vector is in the other side, it's in the third quadrant, then that angle all the way to that third quadrant, it's not pi over 4, right? Even though if you put it in a calculator, it's going to give you tangent of 1 because it's negative divided by a negative, which is a positive, which is going to give you pi over 4, which is not the right answer. So you got to be careful where you're at, and you got to make sure that you know where in the unit circle you're located so that you can find the correct angle for that direction, all right? So in that case, the directional angle would have been 5 pi over 4. So equivalent vectors. Now, what that means is that vectors anywhere in the plane are equal if their magnitude and direction are equal. They don't have to start at the same spot. This one that I have here is in standard position. But if I drew this vector and I took this vector and put it right here with the same direction, right? It has the same angle, and it's out here in the third quadrant somewhere, but it has the same length, same magnitude, then that's the same vector. It's just in a different place on the plane, but it has the same magnitude, same direction. So equivalent vectors have the same magnitude and direction. All right, component form, that's just basically saying what are these two components, x and y. So I draw it with a little arrow, with a little caret, x comma y. It's just the x and the y components of the vector. All right, so let's take a look at how we are going to, calculate each of these things. What kind of questions we'd have. So let's say the initial point of my vector is negative 1, 3. So negative 1, 3 is my initial point. Negative 1 up 3. Okay, my initial point I'm going to put as a dot. My terminal point is where it ends. Terminal meaning ending, right? And that's where I'm going to put an arrow. Now I'd like for this guy to be in standard position. Graph the vector in standard position on the same axis. So what I'm doing is I'm going to take this guy and I'm put him right here. So I'm just going to go over and down, right? Over, down, over 1, down 3. So I'm going to move this other point, the terminal point, over 1 and down 3. Another way you can do this is to take the y's and the x's and subtract. So I can have 2 minus negative 1, which will give me my x, which is 3. I got to make it in component form anyway, so that's 3. And then I could do 7 minus 3, which is 4. And that's my component form, so I'm going to go to 3, up 4, it's right there. And that's going to be my vector in standard position, so B. If I want to find the magnitude, I need it in component form. But once I have it in component form, it's pretty easy. So then my magnitude of my vector is going to be the square root of 3 squared plus 4 squared. Okay? Which is going to be 5. And then I want the direction. So I want this angle here. I'm going to label that as theta. Theta is the inverse tangent of y over x of 4/3. Right, that comes out to be about 0.927 in radians. All right, find the direction of a vector given by negative 3, 5. So what I always tell my students is that I like you to graph out this vector to see where it is. Negative 3, 5. So you get an idea of where and what quadrant we're in. That way we know we're looking for this angle theta here. Now this is our angle, our directional angle. Now if I'm going to make theta right here. I'm going to draw a right triangle. Okay, and I know this is 3 and this is 5. So what I can do is I can go inverse tangent of 5 over 3, all right, y over x, and I'm going to go and get inverse tangent of 5/3, which is going to give me this angle here, and whatever angle I get there, I'm going to go and subtract that from pi, and that'll give me this angle there, which let's call this alpha. All right. So alpha is going to be pi minus whatever I get for theta. So let me go ahead and do that in the calculator real quick, and I'll come right back. All right, so I get 1.030. So I'm going to do pi minus 1.030. which is going to give me 2.111. All right, so that's my angle. So just make sure that you understand what quadrant you're in, so that when you subtract the correct angle, you subtract the correct angle. All right, so let's do the last example here, number 4. If the magnitude of the vector is 6 and its direction is 2 pi over 3, so let's write the vector in component form. So these are really easy here. The component forms are going to be x is going to be equal to the magnitude of the vector times cosine, and y is going to be the magnitude of the vector, we're moving a lot here, times sine. And this is pretty easy because you know that in the unit circle the x goes with the cosine and the y goes with the sine. So the magnitude of the vector is 6 times cosine of 2 pi over 3, and that's going to give you -3. And then the magnitude of the vector here, 6 times sine of 2 pi over 3, and that's going to give you 3√3. And so your answer here is component form, so we want to put little carets, -3, 3√3. Carets. All right, and that's it. So that's a basic introduction to vectors, and next time we'll take a look at some calculus with vectors. All right, catch you later, guys. Bye.